Hi, my name is Jesse Lucas, and my grant was called Newton's Playground. So essentially, my problem of practice for this was, can using wireless simplified sensors increase the efficiency of a lab and therefore lead to more learning and deeper thought about data? So the way that I run my classroom is very Newtonian. Which means I'm not going to be giving a lot of my students the information directly. A lot of times I'll start my unit with a lab, and they'll derive the equations that they're going to use in the unit based on the data that they get from the lab. So the problem that I have sometimes, though, especially with the old equipment that I had, was the students would get so bogged down trying to figure out the procedures of the lab that they really got lost, and they lost sight of the important aspects of the lab, which were the data analysis and finding out what does this data mean and what can we learn from this data. So really, I wanted to figure out a way to use less time on the procedures and then maximize my time on the analysis, because it will only pay dividends later for my students. It'll help them in a lot of different areas. One of the major ones, at least in a high school setting, is with test scores. So with the ACT, it's all data driven. And so is the junior science assessment that they have to take. A lot of it is very data driven. They're just going to look at data charts and they have to interpret the data themselves. So being able to do these labs and focusing less on the procedures and more on the analysis will only help them in the testing setting. It'll also help them in real life after they leave high school. I tell my students all the time, I don't necessarily care if you're going to go into a STEM field, but you still have to be able to look at information and interpret what it means and how you can use it. And that critical thinking and data analysis mindset that they can gain from this could be super beneficial for them well beyond the classroom setting. To implement this, what I decided to do was try and get Vernier LabQuest 3s. So essentially what these are, it is something that you can plug your sensors into, and you can use for pretty much any lab. So I already have a lot of the sensors that I need for it. But the old thing that they would plug into was it wasn't very efficient. So I didn't have to buy any sensors. I just had to buy these LabQuest 3s. I can use them in nearly any lab that I have, regardless of if it's in my physics class or my engineering class, which I also use Vernier sensors for as well. So a couple of the examples off the top of my head is a forces lab and a momentum lab. Now, with an example of the labs, if I really zone into Newton's second law, so if you don't know already, Newton's second law is force is equal to mass times acceleration. So my students would start the unit by getting a ramp with a car on it, and they'd set up photo gates to track how long it would take the cars to move down the ramp, and they could use that to calculate the acceleration down the ramp, and then they know the mass of the ramp. And then they can chart the different relationships to see what the best graph is for the relationship between force, mass, and acceleration. So before I had this LabQuest 3, they actually had to use a spring scale to find the force down the ramp. If you don't know what a spring scale is, it's exactly what it sounds like. You just get a scale, or you get a spring, and you hang your car from it to see how far it goes down. And that's one of the biggest sources of error in the lab itself. And then the photo gates that I use, they're very old. I actually got them from another teacher when I got here, and I'm not going to lie, they're a little bit sticky even, so they're not very good. But I did purchase these new sensors with it, with some of my classroom budget now that I got the LabQuest. But the old sensors, you got to click 3 different buttons to collect the data. And if you misclick the order of the buttons, you'll lose all the data you have. Or it's easy to accidentally click them in the wrong order and think you're getting the data for one thing, but you're actually getting the data for another thing, which just makes it so that there's so many difficult aspects to actually executing this lab well and efficiently. They have to go by the book procedurally. And then once they get their data, they have to manually type it into Desmos, which is a graphing calculator. It's a really nice skill to have, but I would rather them focus, at least in my class, on interpreting the data and not graphing the data. But now, after I have it now, really, I don't have to use a spring scale anymore. I have a force probe that I can connect to the LabQuest. It'll automatically read the force down the ramp, and it'll give it, I think, to the hundredths place, which was overwhelmingly better to the ones place, or to the every even numbers place, like the spring scales I have right now. And all the photo gates are connected to LabQuest. So the students won't have to press any buttons, and it will automatically read the data points, and it will give them the graphs. So they don't have to focus on that other collection of data. They can just get the data from the LabQuest and then look at the graphs, interpret it, and then move on. So some of the possible effects that I think can come from this lab, one of them, like I've said multiple times, faster, more efficient labs. If I can have faster labs that don't take 3 and 4 days to do, especially when I have a class. Right now I have a class of 27 kids. It's pretty difficult to let them get through those labs. I'll have more time for other things, which is awesome, because we lost a lot of time for content this past year. So we've really got to try and make up for it and accelerate these kids the best that we can. It'll also help with the data analysis skills. I've already hit on that a little bit, but I think, not only does it help with test scores, but it reaches outside the classroom as well. Technology skills, which I know the students have gotten a lot of this in the past year and a half, but the more exposure to technology, the better the students are going to be. And especially in a world where technology is completely taking over everything, the more experience they have, the better they'll be. And then collaborations actually as well. I think once I start figuring out how to use these LabQuests really, really well, I can branch out and see if the other teachers want to use it. I know the chemistry teacher, you can buy different probes for the LabQuest. And I know the math department, they could use the data that I get for some other project, whether it be Algebra 1 and it's graphing data, or if it's a statistics class and they can use that data to find statistics with it. So I think the possibility of having collaborations with it is pretty neat. Resources and personnel, really just the resources I need are the Vernier LabQuest 3s. I already have some of the sensors. I'm already in the process of buying some more with my classroom budget, because I think, it's a game changer. And I plan on buying more LabQuests and sensors in the future when I get the money. And then, like I said a minute ago, the personnel, physics and engineering classes, those are my classes right now. There's also another physics teacher here that I'll absolutely let use the sensors. The math teachers could use it. The chemistry teachers could use it. So the sky's the limit, I think. To see if it's a success or failure, a lot of this, you've really just got to go by the data. And for the data that I'm going to look at, I'm going to look at previous standardized test scores for each grade and compare. So I'm going to look at each class after they make it through me, and I try and use these new approaches on these labs to see if their data analysis gets better, and therefore their test scores go up. And then trends on the ACT score, just the same. So the test scores, the state test scores, and the ACT scores. And then I can also formatively assess it with just observations. I mean, I'm in this class with these kids every single day. So and I've already taught the class for a couple of years, so I already know kind of the trajectory that they're on. But hopefully with this, I can see them reaching higher and hitting new limits that other students didn't quite do. And then I can kind of gauge their critical thinking and reasoning skills that are tied to data analysis. And like I said, again, quicker units equals more content. So being able to see how far I can get in the year after it saves me 10, 20 days, that's really kind of cool. And to see I can teach new content that I've never been able to teach. So I'm really excited about that as well. And then summative, it would be really easy for me to use these to collect my own data and then incorporate them in the assessments. Right now, it's quite hard for me to kind of get organic data and put it on the assessment. because of all the hurdles I have to jump through. But now that it's super easy, it would be much easier for me to put some of these data analysis questions and some of the higher level data analysis questions on my assessments. And how I know the correlation is going to equal causation. So the ACT scores at my school recently dipped a little bit. A lot of people say it's due to COVID. It doesn't matter to me. They dipped, and that's what matters to me. So I'm going to do everything that I can to try and get them back up. So with claim, evidence, reasoning, that's kind of the approach that the science department's tried to take. And this is only going to help and improve that that strategy. And it's the only major tweak we're making in the curriculum. So I think that any real growth in this will come from CRE, and in return will come from this new approach to labs. And like I said, watching the individual growth, I can just formatively assess these kids and see how they're doing. So I can see the critical thinking skills from past students compared to my present classes and see how well they're growing.